My grandfather was a tool and die maker at Ford Motor Company for 30 years, and as a tool and die maker he knew how to use a lot of specialty equipment, like this surface grinder. To many, a surface grinder in a hobby machine shop may seem a little bit excessive. It has one specialized purpose of making parts extremely flat, to within a 10,000th of an inch. Of course, within the span of my first project, I already have a need for that kind of precision. How convenient then that I happen to have a surface grinder waiting for its moment in the spotlight. This grinder was part of the shop I inherited from my grandfather, but after sitting for so long, it definitely has some problems. Yes, it's clearly filthy, but more importantly, it doesn't work, and I kind of need it to. Let's see what we can do about that. The surface grinder is the machine tool I am least familiar with in this shop. Up until now, it has been unceremoniously stored in the corner with all of its support equipment. Like the other machines I've restored thus far, there's a decent film of oily dust that needs to be cleaned up. And it's pretty obvious there's something wrong with the table handwheel mechanism. Yeah, that's not how that's supposed to work. On the bright side, the spindle does turn on, and the magnetic chuck still activates like normal. So I'm hoping this will be a relatively straightforward cleanup. Famous last words. I'll start by removing everything I can. So off come the dust collection chute and the plumbing for the coolant system. This will not only make cleaning easier, but will give me a chance to inspect for other hidden problems. The table and saddle seem reasonable for me to lift by hand, so I'm going to get these off of here as well. No sense in making this any heavier than it needs to be, so off comes the magnetic chuck. I would have expected the table to move via rack and pinion, but it turns out it's moved with a steel cable. And it's pretty obvious what the problem is here now. This cable should have a plastic layer on the outside to give it friction on the handwheel shaft, but that plastic layer has completely disintegrated. This will definitely need to be replaced. Alright, let's get this off here and see how heavy it really is. Not too bad. This will be significantly easier to clean on my workbench. I was somewhat surprised to find that the table doesn't move on traditional ways like the mill and lathe. Rather than two flat surfaces gliding along each other, these ball bearings roll on the corners of grooves cut in the saddle and the underside of the table. I'll have to think more about why it's designed like this. In the meantime, I'm going to take these bearings off and give them a nice deep cleaning to remove any grit. There are a few more things tying this saddle to the base that I need to disconnect before I can remove it. These being the crossfeed lead screw, the saddle locking mechanism, and this oil line for the crossfeed ways. The table handwheel isn't strictly necessary to remove, but I don't want it to get in the way. Now let's see if I'm as strong as I think I am. How the hell are you supposed to grab this thing? Okay, this is pretty heavy, so no fancy transition for you. But thumbs up for not dropping anything. Back on the machine base, I made another interesting discovery. These ways embedded in the casting are actually polymer based rather than metal. Neat. What's not neat, though, is I only appear to be getting oil on one side. There must be a blockage somewhere in the oil passage. But before I go opening all that up, I should get all this dirt cleaned up on the outside. All of the paint is in really good condition and is smooth, so the dirt wipes off with ease. Oh, and look, I get to be the first to peel this protective film off. That is satisfying. With all that dirt out of the way, I feel more comfortable removing the way covers. So off come the grinding wheel and shroud. These are the ways for the Z-axis, and they are bone dry. Our oil problem must be more widespread than I thought. Looks like the intention is that the oil is pumped onto the Z-axis lead screw. Then whatever overflows there cascades down and is directed to the ways, and also the spindle. So chances are this spindle hasn't seen oil in a while either. Great. Let's see what on earth is going on. The oil reservoir is at the bottom of this cavity, behind this black cover. This also gives me access to the oil pump. And there would be the problem. There's an oil line that runs from the pump to the distribution manifold, or rather there used to be. I guess just sitting for so long, it completely disintegrated. The pump still runs just fine, so I think our only problem is the tubing, which of course is metric. So it'll have to come from the old interwebs. I'll get that on order and move on. While I wait for those to arrive, I can work on getting everything else ready for reassembly. I'll start with the table. The top surface includes a sort of well for catching coolant, and also this machined area for mounting the magnetic chuck. Scotch-Brite and penetrating oil work well as a first pass. Then saturating paper towels with evaporust and covering with saran wrap to leave overnight takes care of the rest. That's quite the improvement. The underside of the table is a bit more interesting. It contains the ball ways we found earlier. This is essentially a linear ball bearing. Compared to traditional ways, which are essentially linear bushings, ball bearings roll with a lot less friction. A good thing considering this table was shuttled back and forth by hand. I'll give them a nice deep cleaning, a light coat of No. 2 grease per the manual, and move on to the saddle. The top side of the saddle has a matching set of ball ways for the table. They look problem-free as well, so another thorough cleaning is all that's in order. I need to flip this over though to get to the ways underneath. Time to play musical platforms and get the saddle onto the workbench. With that safe and sound, now I can get a good look at the ways on the underside. These match up with the polymer ways we found on the machine base. And just like on the base, one is wet with oil and one is dry. Oil is directed to these ways from a central fitting that branches out inside the casting to the ways on each side. Testing with compressed air, it looks like I'm getting even flow through all the passages. So I'm feeling more confident that my missing oil line is the only issue. Cleaned up, these ways themselves look pretty decent. You can still clearly see the scraping marks from the manufacturer, and nothing looks unevenly worn. This really was a very lightly used machine. There are a few nicks, but these clean up quickly with a whetstone. The last big piece to clean up is the magnetic chuck. The action on this is still smooth, so I'm not going to open it up. I am, however, going to do something about all this rust. The top face will need to be resurfaced once it's remounted on the table, so I'm not going to go to great lengths getting this spotless. From here, it's just a matter of cleaning up all the other little bits and bobs for reassembly. Thanks to the wonders of the internet, the replacement metric oil line arrived just in time. Before I go replacing this line, I'll drain the old oil from the reservoir. Yuck. Probably a good thing that oil line was missing, or I would have been pumping all that sludge into the system. The replacement oil line fits perfectly, so I can button this up, refill with oil, and give it a test. This lube system is designed so that it's pumping whenever the spindle is running. The distribution block splits the oil into 3 lines. One connects to the saddle and branches out to the V-ways. Because the pump is always running, the saddle is basically floating on a very thin film of oil. The overflow oil drains back to the reservoir through this port at the end of the V-way channel. The second oil line goes to this block for the crossfeed lead screw. The overflow is captured in this little moat and is directed back to the reservoir as well. The third oil line goes to a few different places, and it's actually kind of cool how it works. It starts at the top and fills a small reservoir around the Z-axis lead screw. Since the oil is always pumping, it overflows the reservoir and drips down the lead screw onto the top of the spindle housing, where it's directed to a port for the spindle and also the 4 way surfaces. With the lube system operational again, I think I'm safe to start putting this all back together. First is the beastly saddle. With that in place, I can reconnect the crossfeed lead screw, oil line, and the hand wheel. The table mounts on top of the saddle, but before I go dropping that on here, I need to place the ball bearings back on the ways. I'm coating these liberally with grease and roughly centering them on top of the saddle. I also picked up a replacement steel cable for the table. For whatever reason, it's completely absurd to me that I was able to find a replacement at the local tractor supply store. It's one size up from the original, but I'm pretty sure it will work fine. I'm getting this all in place around the hand wheel shaft while the area is still easy to get to. Okay, now to gently set the table in place. Easy peasy. The cable attaches to the underside of the table at each end with these tensioning bosses. With everything adjusted properly, the cable is snug and the winding around the hand wheel shaft is perfectly matched to the travel of the table. That is mighty smooth. Now's as good a time as any to level this machine. The grinder came with these leveling pads for under the jack bolts. The base is on a rolling frame and I know for a fact that my concrete is sloped. Jacking it up off the frame and leveling it will help reduce unwanted vibrations, and also let the coolant and oil systems drain as intended. I'll start with just a framing level to get things close. This is by no means precise enough for the whole leveling job, but it'll get me in the ballpark. With everything close, I can bust out the big guns. This is a precision level and is good down to 0.02 millimeters per meter, or about 2/10,000ths of an inch per foot. It's probably not strictly necessary to have this machine this level, but this is giving me good practice for when I finally level and align the lathe. I'm marking out my positions on the table so that as I switch back and forth, I always get a reading in the same location. Even on this simple machine, this process is very tedious. The slightest adjustment on the leveling bolts can send the bubble sailing too far. But with a little patience, we eventually get there. And just to make sure the level is actually calibrated, we can flip it 180 degrees to see if we get the same reading. The deviation is well within 1 tick mark, so I'm calling that good. I'll get the rest of the parts mounted back on here and move on to the coolant and dust collection systems. This blower is basically a giant vacuum that runs up to the grinding wheel to collect airborne dust. The few times my grandfather and I worked with the grinder, we never actually used this thing, so I'm not even sure it will turn on. But before I go blowing dust all over the shop, I should clean this off a bit. This came with a brand new collection bag, so I'm going to swap that out as well. Now let's see how it works. Well, it definitely sucks. There's still some rust on this, but since I'm not sure how often I'll need dust collection during grinding, I'll just put this off for now. That will give me time to order the matching paint color anyway. One thing I know for certain, I will definitely be using the coolant system. This is the reservoir that holds the coolant and is pumped up to the grinding wheel. The coolant floods the whole grinding area to reduce dust and keep things cool. There's a fair bit of rust and the inside of the reservoir is pretty gross. I'll get the pump off here so I can remove the rust from everything and give it a fresh coat of paint. This sounds like a perfect job for the sandblasting cabinet. Besides the actual machine tools I inherited from my grandfather, this is one of the most used pieces of equipment in this shop. I highly recommend getting one. With all the rust removed, I can move over to the paint booth and give these a few coats of Rust-Oleum. I'm going with a high gloss black for 2 reasons. 1, because the smooth surface texture will be easier to clean, and 2, because this is all I have on hand. Chances are pretty high that the pump is gummed up inside as well, so let's take that apart. Well, color me surprised, everything is fine in here. But now that the reservoir is looking fresh, I can't go putting this tarnished old pump back on there. Should have seen this coming. So I'll mask off all the important bits with duct tape, visit the sandblast cabinet again, and put a few coats of paint on these parts. Now that everything is all matchy-matchy, I feel much better putting it back together. Over on the machine, I can reconnect the dust collection hose and the coolant tubing. Then connect the dust collector and the coolant pump. The only coolant I have is some Cool Mist concentrate, so I'll mix this in the reservoir with distilled water and give it a try. Moment of truth. Dust collector works as expected. Now for the coolant. 2 for 2. Nice. Looks like the containment tray is doing its job as well. The coolant is all flowing down to this corner drain and back to the reservoir. Perfect. I think it's about time we put a grinding wheel back on here. First step before mounting is to make sure the wheel doesn't have any fractures in it. The fractures wouldn't be visible, so we have to do something called a ring test. Loosely holding the wheel and tapping it with the wooden handle of a hammer, I should be able to hear a little note. That sounds about right. Let's mount it on the spindle. Chances are that the outside of this wheel is not perfectly true with the center axis, so we have to trim the outside in a process called dressing. I have this dressing tool that looks like it's meant to be held by the magnetic chuck. To dress the grinding wheel, there are a couple important things I'm doing. First is that the dressing tool needs to be placed just a bit past the center line of the spindle. Placing it here eliminates the risk of the tool getting jammed into the wheel, which would be catastrophic. I'm also marking the entire perimeter of the wheel with a pencil. Since the wheel is all white, there would be no way of knowing how much I've taken off. But once there's no trace of pencil left on the wheel, I know I've dressed the entire perimeter. With the table locked, I'm bringing the spindle down and sweeping the crossfeed back and forth until I get a touch. Once I do, I bring the spindle down about 2 more thou and take a smooth pass across the whole face. With the spindle stopped, we can see the pencil line is completely gone, so our job is done here. Almost. We still need to balance everything. The wheel is mounted to a hub that comes off the spindle. I said a hub that comes off the spindle. That's what I thought. I'll put some reference marks on here and get it mounted on a balancing arbor. Luckily there was one included in all the other inherited tooling. Didn't know what it was until I started doing some research on this topic. Same goes for this balancing stand. Up until a few hours ago, this thing was a mess. What, did you think I would get through this whole project without at least one side project? Not a chance. The theory here is that with the balancing stand level, if the wheel is unbalanced, the heavy side will go down. There are 3 weights on the back of the hub that can be moved around to compensate for this imbalance. Then you basically just mess around with these until the wheel doesn't try to roll from any position you put it in. Looks like I've got it pretty well adjusted. Let's put this back on the machine and do the last little bit of cleanup. It's pretty important for the top surface of the magnetic chuck to not only be flat, but also parallel to the movement of the table. Since I've had this off and on and also cleaned up a fair amount of gunk from underneath, chances of that are pretty slim. Good thing it's mounted to the one tool that can make it happen though. First I just have to find the highest spot. Looks like it's this corner here. Now we just work back and forth across the whole chuck, bringing down the wheel a couple thousandths of an inch with each pass until I see fresh metal across the whole surface. There is one existing damage mark right in the middle of the chuck that looks a bit deeper than I'm willing to take off, so I'll just avoid that area when mounting anything. I can't say I'm pleased with that surface finish. It almost looks like I'm burning the metal. Clearly I need to do a little research. After messing around for a while on a scrap piece of metal, I think I realized my problem. Literally right at the beginning of resurfacing the chuck, I hit the bump stop for the table. When this happened, it caused the table to lurch up, shoving the corner of the chuck into the grinding wheel, and this apparently gummed up the wheel with metal. So I've been rubbing steel on steel from the very beginning. I redressed the wheel, and the results are a lot better. Alright, let's resurface the chuck one more time, and since I'm so close, I'll grind down past that damage mark. Ah, that looks so much better. That's more like what I was expecting to get from this machine. It's practically a mirror finish. Let's take this for a test run on some actual parts. These are the collet blocks I made in a previous video. When I milled the flats, things got a little out of whack. The angles between the faces aren't quite right, nor are the faces actually true to the center axis. So let's use the surface grinder to correct these. There are probably a few ways to go about this, but I'm choosing to use this collet indexer. Don't even ask why I made collet blocks when I already have this tool. Restoring this was a tangent I won't go into, but I'll say I'm definitely mastering the art of the side project. Anyway, my thinking is that I can put a collet in both the collet indexer and the collet block, then use a shaft to connect the two and support the far end. This should let me index accurately to each of the faces. So let's make a shaft. I've been itching to do some lathe work. Since I don't have two of the same size collets, one end will need to be a size smaller. The key here is that the shaft is perfectly cylindrical. This will let me dial the shaft in perfectly horizontal on the grinder, ensuring I'm grinding the flats true to the axis. But it looks like my lathe is cutting a slight taper, about 1.5 thou across the length, which is a little much to clean up with emery paper. This simply won't do. I could try to make slight adjustments to the tailstock to correct this, but really I've been putting something off for way too long. Looks like I'll have to put the collet block project on the back burner, again. Time to actually level and align this lathe. See you next time and thanks for watching.